Hello, my name is Dan Greenberg. I'm the Director of Sales for BitYota. I'm joined here with Halumi Damani, BitYota's Vice President of Products. First, let me thank you all for taking time out of your day today for joining us on this webinar and to learn how you can take 3 steps to analytics on MongoDB data. For those of you who have not heard of BitYota before, BitYota is a data warehouse service, DWS, built to solve the problem of analytics over multi-source data and to solve it on the cloud and to solve it in a way where low latency analytics on data from fast changing web and mobile applications is a possibility. In the course of this presentation, I'll tell you what that means, what low latency analytics means in the specific case of Mongo, and I'll tell you what it means to have delivered a data warehouse service in the cloud, and what it really means to solve for data that's coming in multiple structures and multiple formats in the cloud. And I'll discuss all this in the specific context of MongoDB. The questions we ask are going to differ on a case-by-case basis. But one constant question that always remains is, how am I going to make sense of my data? Typically, our customers are using our products to answer specific business questions. For example, we have mobile and gaming companies as well as e-commerce companies using this, and they want to know who are their best customers. They have millions of users, but which users are the most profitable? How do they increase the engagement with these customers? And where should they target their marketing spend to gain a stronger foothold? So there's a bunch of analytical questions that our users are able to ask of their data using our platform. But most importantly, our platform helps them answer questions that they otherwise wouldn't be able to given their incumbent technologies. Taking a look at MongoDB, we see that Mongo has a lot of great strengths. It's one of the most powerful NoSQL transactional engines. It's great for real-time applications and heavy Web 2.0 applications. And developers really like it for its agility. But Mongo was never designed for analytics. It will struggle to give you complex analytics such as joins across collections. Let's use an example of a blogging site where there's activities, where there's posts and shares and likes. Each of these user-related activities has its own data points that will be stored in a separate data collection. And if you want to truly analyze the meaning of what's happening on your site, you need to understand what activities are stronger, what activities have a stronger correlation to other activities. You need an analytics engine in order to do this, in order to analyze the data that goes across different collections of data. And that's where we come in. BitYota is a data warehouse service available on major cloud providers like Rackspace and Amazon. After the webinar concludes, you can easily sign up and try BitYota right from our website, BitYota.com. We are designed from the ground up for high-performance analytics on a variety of data formats, semi-structured JSON being one of them, and JSON is specifically the language of choice for Mongo. We work only on fresh data, which means we've radically reduced the time that it takes to get the data from a transactional system into our warehouse. We don't rely on traditional ETL, and you don't have to wait till the end of the day or the end of the week to have access to your data where you can analyze what's happened. You could do it almost instantaneously. We are an MPP architecture, which means we scale out based on need. As Paloma will discuss in the demo, we've separated the storage container from the compute nodes. This means that if you have a series of large reports that need to be processed at different times of the day or the year, you can easily add additional compute nodes for the duration of just that activity, giving you more processing power for when it's needed, and then scale back when it's not. You have the ability to scale out elastically. You don't have to wait to buy new machines. It's all cloud-based, so it's easy to grow up or to scale down as you need. And we are particularly agile and flexible because of our ability to use SQL over our database. We are not SQLite. We're not another language that you have to learn. You don't have to program us using JavaScript or Java. We are using SQL 2011. And we're managed service. You don't have the headache of procuring machines, downloading software, worrying about what version of software is running on which machine and when. We take care of all of that. You just sign up to our service from our website, you determine the size of the warehouse you want, and you're well on your way. Now let's shift gears a little bit and let's talk about how you get your data from MongoDB into the BitYota data warehouse. We offer a free downloadable tool for extraction of either all or a subset of your data from your collections. This is a one-time, then incremental data extract and load from MongoDB. BitYota will tail the Mongo uplog at the frequency you request, fetch the new data, then write it to whatever you point it to, whether it be a file system or a cloud system like Amazon's S3. This exported data can be seamlessly loaded as is in JSON format to BitYota's data warehouse. As I mentioned earlier, there's no need for complex ETL and no need to modify anything, even if you have changes to your attributes. This tool can be installed in minutes, and you're literally up and running in a matter of minutes. If you want to try the extraction tool, I'll show my contact information in just a bit, and we'd be happy to give you access to try it out. Once you've extracted or exported your data from the MongoDB, and it's now sitting inside that filing system or inside of Amazon's S3, is then ready to load into the BitYota data warehouse. Note here, we extract your data in JSON, we load your data in JSON. There's no intermediate step that requires us to translate that data from JSON to any structured form. You can use our UI to schedule the load to BitYota, do a one-time setup, point us to your data, and schedule the load. You can either load this data all at once or incrementally, and you can set it to load on a schedule as you see fit. We load data in parallel. We have one of the fastest rates for loading data in the industry. And that's it. Now you're ready to start analyzing your data. The data is then immediately available to view, to analyze, to aggregate, and to join with something as you wish using SQL. Once your data is in the data warehouse, it's immediately ready for analytics. We believe that the process of analytics falls into two major compartments: data discovery and then reporting. For discovery, let's go back to that blogging example. You may believe that the interactions between the shares and the likes of different posts have a high correlation to loyalty. But how do you know that's true? You need to discover that, and you need your data to tell you that truth. Once the data is available in JSON in our system, you can start using SQL over JSON. And we're not just unique in being the only data warehouse that can move JSON forward like this, but we're unique in that we can run run SQL over JSON, and then manipulate that data just like any other column in the table, just like you would do with SQL. Now you're beginning to discover the patterns in the data that your business will benefit from knowing. Once you've done that, once you understand the metrics that your manager, your business manager, your CEO would want, you can even translate that data into columns. After that, you get blinding performance on that column. Our discovery is by far the fastest, but our reporting can be faster by orders of magnitude because you're now operating over a smaller data set. And now your data set is organized in a columnar layout. We streamline the load time by taking the ETL out of the equation. There's no more upfront modeling needed prior to running your analytics, and we're going to be resilient to those JSON changes. What you're going to see in the demo is how we can, 1, extract your data from MongoDB, 2, load your data in its native JSON or BSON format without having to do any type of transformation on your data, and 3, write SQL queries over JSON, all within the confines of a fully managed data warehouse service. running in either the Amazon or the Rackspace cloud. At this point, I'll turn the presentation over to Palomi, and we'll dig into the demonstration itself. My contact information is listed here. If you have additional questions or like to discuss your specific use case, please do not hesitate to reach out to me. Again, we will be sending out the recording of this webinar within a few days. Thank you, and here's Palomi.
Okay, so Dan gave a good, I'm going to say, from a sort of high-level perspective about kind of what BitYota's data warehouse service does. What I want to do is show this to you in action in the context of Mongo. So what I'm going to do is I have a JSON file extracted from MongoDB, and I'm going to it's on BitYota's S3 bucket. I'm going to load it, as Dan mentioned. We load it directly as JSON. Then I'm going to show kind of how you can store it in various storage layouts in the data warehouse, and then just right away run SQL exactly directly on JSON. So that's the demo we'll do, and then we'll take questions after that. Okay, so the first screen you're seeing is essentially our homepage, and this is this is sort of the dashboard that you'd see when you log in. There's 4 steps that we generally see people do. One is log in, launch your cluster if you don't have one already. Then define where your data is located, load your data, and then continue to analyze your data. So we expect the last 2 actions to be kind of more recurring and repetitive, and the first 2 kind of being a one-time or a less frequent setup. So in order to essentially create your cluster, you can just go in here. You have a choice of which cloud you want to go to. So there's an Amazon version and a Rackspace version that BitYota runs on. We have a number of products. There's a sandbox product, and then there's a premium product. Differencing in sort of pricing, power of the nodes, and the number of nodes you can run. I won't spend a whole lot of time in here, but essentially this is where you can, as Dan had mentioned, you can separate out compute versus data nodes, and you can choose to have more compute nodes or more data nodes and grow them as your needs grow or as your data grows. So I have a cluster already provisioned. I'm going to go to the data screen. I'm going to define a new data source. And a new data source, as I said, is essentially where your data is located. So in the case of Amazon, I have an S3 bucket. You would provide sort of read-only access keys that BitYota could then go to fetch data from this bucket on Amazon. So essentially, that's just keys that you create. You give it a name. You can say my test bucket and so on. I have one defined already just to show you what that looks like. I have a BitYota test bucket. Access keys, type S3, and so on. The next action is to define a data set. And a data set in BitYota is essentially a collection of, in this case, related files that belong together. So you want to say all of these files that come in on some schedule, hourly, daily, weekly, belong in one collection. And so that's a way for us to group things together. So let's just go ahead and define a new data set. My S3 bucket, I'll just show you from my S3 organizer in the browser, is under BitYota test, which was our main S3 bucket, MongoDemo, and I'm going to load one file. It's called app data, and it's got the typical Mongo JSON formats. It's got attributes, it's got nested objects, and so on. So let's just pick this particular file, and I'm going to call it my new app data, located on S3. The next thing we do is we'll attempt to recognize a few things about your data set. So we'll actually read your JSON. We'll identify different attributes on it. We can even identify the frequency of arrival of your data if you've set up your data structure correctly, meaning you've got named buckets that have sort of a recurring flow. You could have, MMDDYY or some sort of a flow that we can look at. So the idea is that this actually takes a subset of the data that's located in this directory that you've given us. It'll try to understand more about it and give you kind of, hey, this is what I know about your data. You have the option of overriding it if you want. So let's just use that to sample my data. You can also skip this and provide this information on your own. So this is going to do a few things. It's going to discover stuff about your data. It's going to discover a schema, including your JSON schema. It's going to discover data arrival patterns in the file. If you have a standard naming pattern for your files, it'll discover all of that stuff. Again, this is the best effort because it's going to look at a sample. It's not going to look at the whole, potentially terabytes of data on S3. But it's a good start for you to get going. So this will take a few minutes. In the meantime, let me show you kind of a pattern that we expect for recurring data. So if I were to look at my S3 Firefox organizer, this is the kind of patterns that we'll see. So in this case, it's data coming every 5 days. So you can see it's listed as, YYYY, MMDD, and then sort of hour and minute. So this is coming actually at every 5-minute intervals. So if we saw this pattern, we'd say, hey, data arrives every 5 minutes for this data set, and we can pick it up. And so now you can see we've discovered there was no file naming pattern. There was only one file. So it says pick up everything that's in this one base bucket. We found a record delimiter. We expect one record per line. There's no new data coming in. It's one thing. You can specify how long you want us to wait. If you have processes that are writing to a particular directory and you want to wait for this process to finish and then pick up after that, you can essentially specify a latency on your data. You can pick the time zone that your data is going to arrive in, and we'll keep that. This is all important if you have a recurring schedule. And I'll show how to set that up. So you can see we've discovered it's JSON. You can see it's a nice nested JSON. We'll give you a sample of the first 3 rows. And I'm going to leave it as JSON. I'm not going to exploit it any further. So I'm just going to save my data set. Excuse me. And here's my new data set called My New App. And now I'm going to load this into my cluster. And this is where you can get a lot more sophisticated about how you load the data. So again, destination table name, by default, it'll take the same name as your data set. If you have multiple clusters, you can choose, for example, if you have a test and a dev and a production cluster, you can choose to send your data in different places. This is the schema we discovered. So if you look at your JSON schema, we've discovered the top-level attributes inside it, and we've assigned a default data type to it as well. So for example, L is an array. And we've said, okay, it's a JSON inside of a JSON, UV, etc. T is a timestamp, V is some text, and so on and so forth. You can choose if you know you're always going to query on, for example, U, which is user ID, and you want to take that out of the JSON and create a physical column for performance. You can do that right here. So you can say, hey, not only do I want to load the JSON as a single column, but I also want to load U out of that JSON as a separate column, right? So this is possible directly from here. So that's the schema. The next thing is table structure, and this is where, again, depending on your analytical needs, you can choose columnar or row. Columnar is good if you're going to do a subset of attributes. We have partitioning schemes on it. If you decide to generally look up data on a time series basis, you want to look at the last hour, the last day, the last week, you can do range partitionings. And you can also do subpartitioning. So we allow you to do a partition and a subpartition. So I'm going to leave it as random. It's in a single file. The next thing that we can do is pre and post steps. And this is really sort of a way to build a very simple pipeline. You might want to do data validation checks before you load the data. So you can just write SQL. There's a bunch of available UDFs that you can plug in. So our SQL allows you to run user-defined functions that are script-based directly within the SQL. And you can do, for example, So the step is one or more preload steps, data loading, and then a post-load step where you can do validation again, you can do aggregation, you can do counts, all of those things. And you can choose to run this on a schedule. So that's sort of a simple data pipeline. And then the last thing is a load schedule. So we talked about this is going to be a one file, so it'll be a one-time load. But for example, if you wanted to load archive data in a one-time load, you could specify a range. You can say bring data from start date, last year, 10 a.m. to this year. Or a recurring load, and this is where some of the things that we looked at earlier when we were looking at the data set, the wait time, and so on, comes into play. So this is essentially a recurring schedule that's built into the data warehouse. So on that schedule, for example, if I say every day I want to go to that directory and load whatever is the new data starting at 10 a.m. Right? So that's a recurring schedule you can set up. So again, as Dan mentioned, no need to do a separate ETL, no need to build a data pipeline outside. You're loading the data as it's arriving according to your rules. You can do validation checks right within as it's being loaded and create sort of aggregations, subset tables, and so on and so forth. So all of this is a quick one-time setup, and you're good to go. So we'll leave it as one-time load because there's really not a whole lot of other data in there. And I'm going to go ahead and load it. And this is now going to go off, create my destination table, partition it the way I wanted it, and then take that file and load it. In our case, it's a single column JSON. So you'll see that when I go to the analysis page. So data has arrived in JSON. It's located on S3. We found it. We discovered its nature. And we loaded it exactly in its raw format. So no changes have been made. And you can see this process is, pretty simple and pretty streamlined. There's not a whole lot of other stuff you need to do. And then if you have data loads, you can obviously see what kind of history and so on you have within this particular data set. So that gives you some auditing capabilities as well. While that's processing, I can go to, and that data set is ready. I can go to the analysis screen, full-fledged SQL workbench, but it's there for you to do quick SQL queries, potentially schedule queries that can run against this, continuously arriving data. So what I'm going to do here is I'm going to show you some basic SQL over JSON, and then we'll go into a BI tool like Tableau, and I'll show you how to do sort of more visualization on top of that as well. So let's look at a new query. You'll see a list of tables on the side. So the first one is, let's look at what the JSON column was, right? So I'm just going to say my new app. And just to show you that we've just loaded the JSON exactly as JSON. So I have a table called my new app. I have one column called JSON_column, and I just used SQL to fetch the entire JSON, right? Now what I want to do is I want to fetch an individual attribute inside this JSON. So let's look at U, which is user ID, and that's pretty simple. I just do an arrow, and I can cast it as user ID, and I can say limit. We only have one. Let's look at the first 10 records on this, right? So essentially, I've taken U, which is a virtual column, and I've treated it exactly like a physical structured data column. And you can see that we're going to go and fetch the first 10 records of U from the data that we loaded, which is app data. And here's a list of U. So data is in JSON. I managed to extract just a single attribute out of it, treated it like a column, and you can do all sorts of computations and functions on this. So this was just a straight up first level attribute inside of JSON. What about nested objects, right? So let's look at a nested object, which I think was let me just see what I called it. Yeah, let's get an array, which was in our case, it was L, which was an individual element inside our table. So in this case, what I'm doing is we have a UDF called getItem. GetItem fetches arrays inside and presents the results as an array. So in this case, I'm fetching an array called L. And you can see, this is our array of nested objects. So I've gone one level inside. What about if I want to go even further? If I want to pick E, I want to list all attributes called E, data associated with E, inside this nested array. So let's get that, right? So I want to say select. Essentially, what I've done is I'm fetching an attribute from inside our array, and I've named it as an object, right? So it's the same query. I'm now going one level inside my array. And you can see I've now got just a bunch of events from inside the nested object. I can do distinct. For example, I want to do, just give me the distinct events that are available, right? So distinct, count, group, like I said, all of those are available as SQL operators directly on top of this. So you can see there are 3 distinct events, right? Change directory, log, and app start. Again, the purpose of this is to show you how to do SQL over JSON, and then this particular essentially allows you to quickly discover your data. Potentially, you could schedule a query right here. So this can say, this particular query, just check and run it and store the results somewhere on an hourly, daily, etc. basis, right? So this is again the end of your pipeline. So you've loaded your data. You've analyzed it, and you're running a scheduled query, which is great for sort of reporting and so on. And needless to say, given this sort of SQL format, I can join across collections. So potentially I could do, find me user ID from my user collection and my events collection, and join those two together, which is something that, it's unless you take it up to the application, it's impossible to do inside of Mongo using straight up querying, right? So this gives you the power and flexibility of SQL directly over your Mongo data, and it's using SQL, which your analysts and everybody, even people coming out of school, can understand. So that's sort of the end of the demo inside BitYota's UI. I'm just going to take it one step ahead, which is to show how you can put a BI tool such as Tableau on top of it, right? So in this particular case, that query I used, which said select JSON object, that I've done here already. So this is my JDoc, and just to show you, it's similar. It's the same data that we've loaded in our database, right? Now the interesting thing I can do with this is I can explore these parameters as counts and measures. So I've created my own dimensions. I had nested objects called parameters, so we can see that. Right, so these are just a simple tabular format of my data. I can do measures on top of it, so I can count the number of records. I can count. So, for example, I want to say how many events of a certain type happened in the past quarter, right? So that's a very simple visualization we can do right here, right? So in this particular case, I've done, in the month of October, by event type, what are my counts, right? Very simple great visualization for somebody trying to understand how many new registrations I got, how many new events I got for a particular new feature that I've added, right? So this is a quick way using a standard BI tool on top of your semi-structured data, allowing you to slice and dice and discover your data. That's mostly the end of my presentation. I'm gonna stop right here and let's take some questions.